Hi, this is Dr. Bill Cardozo from Creative Electron, and in today's presentation we're going to cover several different X-ray applications that do not include, the typical PCB inspection. Today with us is Dr. Glenn Thomas, who's our VP of Marketing, and he's going to run the presentation for you guys today. Hope you enjoy it. Glenn?
Okay. Typical applications with X-ray, LED packaging. That's become a large market for us based on the fact that luminaries create quite a bit of heat, and the heat distribution is really key in the lack of voiding, essentially how well you have it glued to the board. And, we've done really well at being able to pick out that voiding. Semiconductor failure analysis. Essentially, if you have a failed component, you could have a lot of different areas in the component. You could have solder issues. You can have overfill issues. You can have die issues, bond wire issues. There are quite a few processes that X-ray is invaluable when it comes to semiconductor type applications. Counterfeit component detection is a huge one for Creative Electron. We spent a lot of years developing software algorithm, a great job at giving you probability. We can do a pretty good percentage of probability based on the components themselves in their similarities. Counterfeit component detection is a big industry, but again, that's like BGAs. A lot of companies look at the counterfeit component aspect as a separate individual being. Any contract manufacturer could offer counterfeit component detection as part of their customer service package and actually add value to their products and to their customer service. But a lot of companies will look at X-ray in the tunnel vision and not look at the overall picture. Counterfeit component detection is one of those that really is an added value to the customers. Electronic component manufacturing. Again, this is die inspection. It may be, fill inspection, and you could even look at, again, the wire sweep and that type of applications. A lot of times when you're adding components, like a chip on a chip, some of the dies and some of the voiding really does stand out. In this case, you can see the voiding in that component fairly easily. Plated through hole, PCB inspection. As PCBs get a lot more and more layers, and you get multiple layers with smaller surface mount components, traces and plated through hole analysis is really becoming a key factor. And we do have software algorithms that are available for doing plated through hole barrel fill analysis and that sort of stuff. Smartphone design and manufacturing. There are a lot of key things to look at in a smartphone. You've got surface mount components. You have some flex components occasionally. The biggest key driver in the smartphone industry is the battery inspection. You want to look at the batteries, and in some territories, the batteries cannot leave the factories unless they're X-rayed. So X-raying cell phone batteries is a huge market. And essentially, you're looking at standoff distances. If you drop the phone, are you going to short the battery out? So you're looking for leads, you're looking for distances, and you're looking for standoff distances in the battery. Worst thing you can do is drop the phone and then put it in your pocket and the battery explodes. So that is a real big industry right now for X-ray. And again, that's another one that's driven from a need basis, just like BGAs and just like LED components. So it's, found it, X-ray is the best application, or that application is best served by X-ray in general. BGA head and pillow. BGA is the big one. BGAs actually really came about 20 years ago. X-ray companies had no clue what a BGA was. Manufacturers started placing BGAs. There were all kinds of specifications all over the place, from zero voiding to 50 75% voiding. Nobody really understood how to place a BGA or what it meant. And it was actually a boon to the X-ray industry because now we could look at something and we had a defined need. And then with that, we could define some answers. Up to that point, all X-ray companies kind of just built a system based on a need. If you had a problem, we could build a system that would help you identify that problem and control that process. So BGAs really helped the X-ray industry standardize what we would call a electronics inspection device. Essentially, we're looking at percentage of voiding, we're looking at circularity, we're looking at bridging, the size of the balls, and with some experience and some algorithms in our software, it's very easy to do a BGA analysis and BGA inspection, and then we have enough experience to be able to tie those inspection results back to your process. Essentially, I can look at a BGA or look at a solder joint, and I can give you some ideas as far as are the problems in your temperature of your temperature profiles, or maybe you've got a dirty silk screen, or you just need to go in and stir up your solder flux. In a lot of cases, we can look at the X-ray and we can determine based on the profiles we're seeing, we can determine where in your process you need to look for your problem. X-ray, again, for BGAs, as well as for all electronic components, is not a silver bullet. Just because you buy an X-ray machine and put it in your building, all your process problems aren't necessarily going to go away. You have to understand what you're seeing in the X-ray, and then you have to have the ability to compare that information. So the database concept of the X-ray system becomes key. You have a database of images and a database of results, and you can compare those images and results to the point that you're able to look at the image and say, yeah, we had that problem once before, tie that image back to your database, and then look at it and say, that was definitely this issue. And a lot of times you can see your process drift by looking at the X-ray images. Your process hasn't failed at that point, but you do have a drift, and that drift is easily corrected prior to sending bad boards out the door. RF components and systems, essentially X-rays look through the product. As we get later into the presentation, I'll explain why and how that works. But essentially, you're looking all the way through the product. So if you have heavy heat shields or you have RF shields, typically X-ray is not an issue. You can actually throw the part in. I always get a kick out of going to a place and we're demoing X-ray, or I'm setting the X-ray system up, and someone brings me a board that needs to be inspected, and they take it out of the ESD bag. And it's always, because I always get a kick out of that. You really don't have to take it out of the bag to X-ray it. I mean, that's essentially why you're buying an X-ray system. So RF shields, shielding, heat sinks typically aren't a problem for most X-ray systems. Automotive parts, another big industry for the X-ray systems. You have a lot of encapsulated epoxy-filled parts. You look at a connector. Most of the connectors are epoxy-filled and coated and sealed with O-rings, so their watertight integrity stays in place. ABS brake modules are a big one. You have a lot of electronics inside of there. You have a lot of wires connecting a lot of components. And something as simple as an automotive mirror has quite a bit of integrity inside as far as parts and placement of things. So you really need to be able to see how that mirror goes together when the clamshell snaps in place. So automotive industry, and then you get into the die casting portion of things. A lot of the parts are aluminum die casts, and the aluminum die casts are easy. You can look at circuit boards through aluminum die casts as well. So if you have a module attached to a throttle body, it's pretty easy to see the module and see the wires that are attached inside. Non-destructive testing and evaluation is a catch-all. It's a big bucket where everything that doesn't fit in as far as components and electronics kind of go into that. This case, we're looking at the non-destructive. We're looking at a heating element inside of a hairdryer. You can look at all different types of components. You can you can look at the integrity of the components inside. You can look at the placement of the components. Again, this is another one that most companies miss. Circuit board manufacturers tend to make circuit boards, but occasionally these contract manufacturers also finish and build product. They take those circuit boards and they put them inside of a product. And they have problems with their products as an assembled component, but they never think to go back and use the X-ray to try to diagnose those problems, because the X-ray is only for BGAs. You wouldn't want to look at plastics or how your components fit together as a whole. So we always push that non-destructive testing is ideal for general X-ray use. Parts presence and placement goes back to that portion. Essentially, we're looking to make sure that all of the parts are where they're supposed to be and they're connected in general. If you have a case of parts and you want to make sure that you have a screw involved. I've had people come to me with basic applications like we have 1,000 cases of XYZ and we think that we may have left a screw out of the package. Rather than tear all the boxes apart and determine if they have a screw, they'll take 10 boxes and X-ray them and get a general count and say, yeah, there may be a couple without the screws, but we'll live with that. A lot of times parts presence and placement companies will look at it and determine their liability. How many problem components do we have, or how many problem parts do we have, and is that an acceptable number for our warranty process? If not, then we won't ship it, but if it is an acceptable number, then we'll ship them and worry about them later. So parts presence and placement is really a problem and specific problem-driven application. And that can range anywhere from Barbie dolls to bombs. It really depends on what you're looking at that point. It could be food applications as well. Plastic and aluminum molding. Plastics and aluminums especially for automotive applications, are really key. Aluminum part weighs a lot less. If you're using it for suspension components, you eliminate 10 pounds out on the suspension, and it does give you much better fuel economy. Just your overall weight savings in the car works really well. The problem is in the manufacturing process, you have liquid that's flowing essentially, and you can control that flow with your molds and your pressures. But essentially, you want to make sure that your molds are set up properly and that you're pulling with the flashing, you're pulling away any porosity or voiding. So voiding in aluminum components is really a pretty important key in making aluminum components. You don't want to machine a component and then find that after you've machined it and threaded the component that you have bores that have holes. You can't seal up with gaskets and you can't seal it with O-rings. So aluminum and plastic molding is a big one. If you look at all of the different aluminum components, even to the point that heat sinks, a lot of companies, you buy your heat sinks, and a lot of times what you'll do is they've got some issues. So you may have some heat issues on your components, and it's because you've got a poorly molded heat sink. Medical device design and manufacturing, that's a key issue. There are a lot of things with medical devices. You're covered under GMP, you've got ISO. So there are, but the key is you really have life and death decisions made with your product. Like in this case, if that spring is not seated properly, that may actually kill someone. So that's a key. Parts present and placement's kind of part of it. Also, say in bottle fill inspection, or if it's an FDA controlled product, if you say you've got 100 milliliters of product inside the container, and typically with the FDA, you have to have a plus or minus of 10%. If you have more than 10%, you're in violation. If you have less than 10%, a lot of times if it's a surgical pack that's been sterilized in an opaque container, you want to make sure that you have everything necessary when the surgery begins. Last thing you want to have is a part missing. So a lot of medical devices are x-rayed on a regular basis just to make sure they have all the parts available. Worst thing you want to do is have someone's hip torn open and discover that you don't have any screws, and while they're under anesthesia. Mm-hmm. So medical device and manufacturing is pretty popular. A lot of times when you bring big things back from the field, why did it fail? Did we have a weak point in the cable? Does it not hold up to home use? Somebody dropped it. You can actually do an analysis of the product when it comes in the door and give your R&D and your engineers a heads up as far as putting the information in the database, and then you could look at trends. The database would also allow you that if you did x-ray this product prior to shipping it, it would give you a indication of maybe that spring has dislodged, maybe the seal is, something's changed in the seal. By being able to look up with keywords and with tags and operators as well as dates and serial numbers in the database, you could pull that image up and compare it with the current image of the product that came back. And you can look at it and say, it gives you a better understanding of what may have happened in the field. So the database function is really huge, and that is a major move forward in the use of x-ray in manufacturing in general. Small animal imaging. That's a controversial thing that all advances in medicine are typically based on research done in research universities and pharmaceutical companies. And essentially, you take the x-rays of mice and zebrafish. If you have bone issues, if you're working on circulatory issues, if you're working on tumors, x-rays are key to that. In this case, we want high-resolution x-ray images. Typical medical x-ray is not high enough in resolution to see the structures of the bone or to see the muscle tissue. The FDA doesn't regulate small animal imaging to the point that they regulate medical x-ray. So we use a lot of soft x-ray to be able to give us tissue definition that you would not necessarily see in a medical x-ray system. So small animal imaging is another big one. It's very specialized, and typically you're looking for specific application type stuff. Seeds and agricultural imaging is a huge business. If you have 1 million seedlings and you want to plant those, how many of them are going to be viable? You don't want to plant 1 million trees and only have 3 grow based on a damage that may have occurred in shipping or their root structure is flawed. So essentially you would take a bunch of those seedlings and take a look at them, look at their cell structure, look at their root structure, look at their ability to suck water out of the ground, and determine based on that you will have X amount of viability when you plant them. A big one is seeds. If you get a mill that makes, say, flour for cereal, they'll have a train car pull up full of, say, wheat seeds. They will take a measured amount of wheat seeds, x-ray them, give you a percentage of infestation for in the wheat seeds. If it's less than 20% infestation, then it's cereal. If it's more than 20% infestation, then they're going to be making dog food. So essentially, the seed and agriculture is huge. Most people don't realize the amount of x-rays that are taken on both of those applications. So x-rays have a lot of benefits outside of contract manufacturing and electronics.
Thanks, Glenn. If you'd like more information about this topic or anything else related to x-rays, please contact us at 760-752-1192, or check us up online at creativeelectron.com. Thanks.